Okay, where we left off in the last video was at the bottom of example 8. And actually I think I emphasized a lot on the fact that I squared is just equals to -1. So I've just written down here for clarity before we proceed, okay? As a result of this, you will see that I cube is just minus I power 4 is just 1, and I power 5 is just going to be I power 4 times I. So it's just 1 times I, which is just I, which is just root of -1. So in general, I has the property where I raised to any power n is just going to be equals to I raised to the power of n minus 4, n, which is equals to I raised to the power of n plus 4. Okay, because you can see from this box over here that it just repeats, right? Do I need to explain this? No, I believe it's quite intuitive. Okay, before I move on, this video is actually supposed to cover the major part of this topic, which is on solving polynomial equations. But you will see in your notes there's actually a couple of examples before that, examples 9 and 10. I have chosen not to go through these in detail because they are quite self-explanatory. Um, th I've already showed you how to compare real and imaginary parts in example 8. So please look through example 9. It's not very often. I'm not sure. I don't recall if there's a question in tutorial 10 or not that asks you to find the square roots. But please look at example 9 to show how you should find the square roots. It's really quite intuitive. It's the same scale as we learned last time already on how to compare real and imaginary parts and then sub in and etc. And then for the subsequent solving, you can just sub this in and use the quadratic formula. So you may actually have to use the quadratic formula directly in a lot of questions in complex numbers. But I'm choosing not to go through example 9 because it's quite self-explanatory. I showed you the scale already earlier in example 8 on comparing real and imaginary parts. Okay? And I suggest you, if you don't believe that the explanation for example 8 is clear enough, I suggest you copy over my working into your notes on example 8. Okay? And there's also example 10, but it just makes use of factor theorem and also long division and also the quadratic formula. Really, all of this you actually learn in secondary school already. So I'm choosing not to go through because actually, in this case, is solving these kinds of equations involving complex numbers is actually not that different as compared to solving for real numbers. So because you have learned all these skills already, I'm not going to go through them. Anyway, now we are at this particular section over here, page 15 of your notes. And as you can see here, there's a very important theorem, which is that pz must be a polynomial with all coefficients real. And if a complex number is a root of the equation, then its conjugate is also a root. In other words, if z is a root, then z conjugate will also be a root. Okay, and this is the conjugate root theorem. There are questions, okay. I think there's a question in your tutorial 10. I don't recall which, but I remember there's a question in your tutorial 10 that explicitly asks you to write out in words this conjugate root theorem. And I hope you're prepared for writing out in words because this is your last topic of pure math. Um, and as you go into statistics, there are a lot of worded questions, especially in your chapters S4 and S5 on sampling and hypothesis testing. So get used to writing a bit in math. I know it may seem a bit annoying because you don't really expect to be writing sentences in math. But sometimes if the question asks you to state an assumption or state why or explain why in words, okay? Don't be afraid to write out in words. Make sure you communicate your idea clearly. Okay, so how you apply this, I am going to the notes only has example 11, but I personally don't think that's enough. So I'm going to go through one of your tutorial questions later as well. Okay, but in the meantime, I'm going to explain example 11 first before we go through one question from tutorial 10 to put it all together. Okay, so I'm going to handhold you a bit for this part because it's very important. I'll show you these two questions and then after that you can actually do most of your tutorial 10 already. I will check again which questions you can do based on what you've learned so far. Okay, so example 11 says that given that z equals to minus I, so they give you quite a simple one. It's just minus I. So given that z equals minus I is a root of this equation, z power 4 minus 2z cubed plus 18z squared minus 2z plus 17 is equals to 0. They give you this, and then they ask you to find the rest of the roots without the use of GC. So without the use of GC means that there are a lot of things that you want to do that you cannot do already, right? So that sucks. But we can already see that at least, right, we can know that because all the coefficients are real. Oh, that's terrible. We know that because all the coefficients are real means that we can actually apply the conjugate root theorem. A lot of times, right, this kind of question will be about 4 marks, 5 marks. And just stating and applying the conjugate root theorem is enough to get you 1 mark. Okay, so please don't underestimate the power of that one sentence. Depends on the mark scheme, right? Some mark schemes will explicitly say you cannot get the full method mark if you don't write the conjugate root theorem, that sentence on top out in full. So please, please, please don't be lazy to write words, okay? They can and will be method marks for writing words. So let's P Z equals to this. Just copy over. And as you can tell, they almost always give you quartics or higher, quite a high degree of polynomial. To frankly, it's really just to make your life harder. Anyway, since or because PZ, you explicitly need to write has all coefficients real, and minus I is a root, therefore I is also a root. Some other schools mark schemes will insist that you explicitly tell the examiner that minus I and I are a conjugate pair, but for Hwa Chong we don't need that, so that's why it's just like this. Okay, so when you are given a quartic equation, go back to sec 3, sec 4. What do you do when you are given a root and you are given a quartic equation? Obviously, in this case, we are given two roots, right? Z equals to minus I is a root, and Z equals to I is also a root. So we can actually find a quadratic factor um, by multiplying the two linear factors together. Actually, at this point, I do want to go back a bit to. No, it's not example 9. Okay, I'm sorry, I mixed up two questions in my head. This is the first time that you're seeing this. Okay, so anyway, because I know I have a linear factor, I can just write it out the same way as we used to write in sec 3 when we were doing remainder factor theorem. You remember that? Actually, a lot of this topic, right, is really just going back to your sec 3 work on solving polynomial equations. There's no point pretending that it's any more complicated than this. It's just that we're replacing your real unknowns with complex unknowns, which makes things a lot scarier. But really, this topic can be quite easy because most of the skills you learned in sec 3 already, ma. Anyway, so because z equals to minus I is a root, so what's one linear factor? Z plus I. And z equals to I is also a root, so what's another linear factor? Z minus I. Factor theorem. Ta-da! And then therefore, uh, different teachers will write in different ways, but I'm just going to use the way that most of you have probably been exposed to since sec 3, sec 4, which is I write the unknown quadratic factor as just az squared plus bz plus c. Okay, so obviously you combine these two linear factors, and I will get z squared plus 1 times this. So once again, go back to your basic sec 3 work. When I had this kind of equation in sec 3, where they give me one root using the factor theorem, how do I find the other quadratic factor? Long division. Ta-da! Okay. I know you probably haven't done polynomial long division since the end of Sec 4. It's definitely been more than 13, 14 months for y'all. So I'm gonna show you how to do polynomial long division again, right? Because I know you probably have returned this skill to your Sec 3, Sec 4 teachers already. Copy this over. And you will run out of space. It's okay. If I'm not wrong, right? I think what you've probably been used to in Sec 3, Sec 4 A math is usually they don't give you quartics, right? They give you a cubic equation, and then this thing is a linear factor. But in this case, it's a quadratic. They give you one quadratic factor. It's the same principle. Okay? And then over here, I have z squared plus 1. So we are going to relearn how to do polynomial long division. First, sorry. First, what is here? Z power 4, right? So I'm going to use a different color, okay? Obviously, what do I need to write on top here? I need z squared, right? So make it a good habit to align all the terms of the same power together when you do your long division. So z squared times z squared here, that only can get z4. Okay, so z4, and then z squared times 1 is just z squared. So I make it good practice all the way from Sec 3, Sec 4 A math. I'm not sure what's the way that you've been taught in the past, but personally, my good practice when doing polynomial long division manually is to put this minus in the bracket. Because one of the most fatal mistakes that you can make when doing polynomial long division, I'm sure you know from Sec 3, Sec 4 already, is wrong sign, then everything gabra. Anyway, so z4 minus z4, 0. This one carry down. This one, 18z squared minus z squared. I still have plus 17z squared. Okay, next term. I want to something times z squared to eliminate my minus 2z cubed. So obviously, this needs to be minus 2z. So minus 2z times z squared, I can get my minus 2z cubed. Then I eliminate this. And then minus 2z times 1 is minus 2z. Okay, so this one is eliminated. This one, 17z squared plus 2z squared. I get 19z squared. No, 17 minus... okay, sorry. That was a brain mistake. So, this is just going to be... This is the z term. So, you should align it with the z terms. Aha, you see, I made a mistake. You should make sure that all your terms of the same power are aligned. Okay? I'm sorry, I just made a mistake. I hope my mistake has just shown you why it's so important to keep your polynomial long division neat. But anyway, in case you haven't already picked up this good practice from Sec 3, Sec 4, now is the time to learn it. And just nice, I've eliminated this, I've eliminated this. The only thing left to eliminate is this. So just nice, plus 17. Then you see 17 times z squared, 17z squared plus... Sorry, let's not make that mistake again, okay? Align it, and then I will get 0. There's no remainder because it is a factor. That's how I know I've been doing things right. Okay? So, ta-da! I've just reactivated a skill that you probably returned to your Sec 3, Sec 4 teachers long time ago. So I hope this makes sense to you. Polynomial long division. And so therefore I can express pz as the product of these two factors. Okay? Z squared minus 2z plus 17. So, this means that by a very important theorem that you learn in Sec 2, the zero product theorem, this means that either z squared plus 1 equals to 0, or z squared minus 2z plus 17 equals to 0. Okay? By the way, there's no app on your TI-84 that can do your polynomial long division for you. So really, the only thing that makes your life harder because of the question say do not use GC is the solving this manually. But obviously, we know how to solve this thing manually, right? By quadratic formula. So obviously, our z squared plus 1 equals to 0 just gives us z equals to plus minus I, which we already know. So we also want to solve this, right? So z squared minus 2z plus 17 equals to 0. So quadratic formula, minus b plus minus b squared minus 4ac over 2a. Okay, I'm not going to bother expanding and evaluating this for you, but basically, this is just 1 plus minus 4i. You can simplify it to convince yourself. Okay, so therefore, the other roots, because it said to find the other roots, what? So you must present your answer with the other roots. I, 1 plus 4i, and 1 minus 4i. Please do not leave your final answer as plus minus. Be clear, like that. Okay, Ken? Yeah, I hope the most important thing that you have learned from this question is relearn how to do polynomial long division. I think it's a bit rusty for you already. And as you can tell from my basic math mistake, it's a bit rusty for me also. Okay, uh, I think I'm going to split this video in two so that you can think about this properly. And in the next video, I'm going to want to I'm going to want to hold hand with you and go through with your tutorial 10 question 5 here. Because this question, I feel, really puts everything together from what we just learned all the way to what we learned earlier in solving linear, solving simultaneous, comparing real and imaginary parts. So I want to guide you through this question because it puts everything that we've uh gone through together so far, and then you can actually already go through. I mean, you can already do your tutorial 10 question 1, 2, 3, 4, all the way to all the way to question 5. Yeah. So next video I'm going to go through this with you, and then you can do 1, 2, 3, 4 on your own. Okay, bye bye.